Hi, Daniel. Good day and welcome to your DevOps interview. I'm Sanjay, and I'm thrilled to have you here today. Your impressive resume has caught my attention, and I am eager to learn more about your skills and experiences in DevOps. I have prepared a set of questions to explore your expertise further. Are you ready to begin?
Thank you, Sanjay. I'm excited to be here and ready to answer any questions you have about my experience in DevOps.
Please give an overview of DevOps principles and practices.
DevOps is a set of practices that combine software development and IT operations to reduce the time between committing a change to a system and the change being placed into normal production while ensuring high quality. The principles of DevOps include collaboration and communication, continuous integration and delivery, infrastructure as code, automated testing, and monitoring and logging. By implementing DevOps practices, organizations can deliver software faster, with higher quality, and with more reliability.
Can you explain the DevOps culture and mindset?
The DevOps culture and mindset is centered around collaboration, automation, continuous improvement, shared responsibility, and customer centricity. It involves breaking down silos between development and operations teams, fostering communication and collaboration, and creating a more agile and efficient approach to software development and operations. DevOps emphasizes a focus on delivering value to customers, with teams sharing responsibility for delivering high-quality software through end-to-end ownership and accountability. By adopting a DevOps culture and mindset, organizations can create a more customer-focused, efficient, and effective approach to software development and operations.
Can you explain the DevOps organizational structure and team roles?
The DevOps organizational structure and team roles involve a move away from traditional siloed structures to more flexible and cross-functional teams. DevOps teams typically include developers, operations professionals, quality assurance engineers, security engineers, and other specialists who work together to deliver high-quality software. The specific roles within a DevOps team can vary based on the organization's size, complexity, and needs. The goal of this structure is to foster collaboration, communication, and shared responsibility.
Name some DevOps communication and collaboration techniques.
DevOps teams rely heavily on effective communication and collaboration to streamline workflows and deliver high-quality software. Some DevOps communication and collaboration techniques include agile methodology, ChatOps, Slack, Teams, stand-up meetings, and cross-functional teams. These techniques improve communication and collaboration between development, operations, and other team members, ensuring that everyone is aware of what others are working on and what issues need to be addressed. By adopting these techniques, DevOps teams can work more efficiently and effectively, delivering high-quality software faster and with greater reliability.
Please explain what continuous integration is and how it works.
Continuous integration, or CI, is a DevOps practice where developers frequently integrate their code changes into a shared repository, and an automated build and test process is triggered to detect and resolve issues early in the development cycle. The key concept behind CI is to ensure that all code changes are tested and verified before being merged into the main codebase, thus avoiding integration problems and reducing the risk of regressions. CI helps to catch issues early in the development cycle, reducing the time and effort needed for debugging and testing, and encourages collaboration and teamwork among developers.
Please share an example of a time when you explained continuous integration to someone, and describe what you taught them.
So, there was this new intern named Tom who joined our DevOps team. He was eager to learn about the different tools used for continuous integration in DevOps, and I was assigned to mentor him. I started by introducing him to Jenkins, an open-source automation server that's widely used for continuous integration and deployment. Jenkins supports various programming languages and integrates with multiple tools, making it a popular choice for many development teams. Next, I told him about Travis CI, a cloud-based platform that supports multiple programming languages like Ruby, JavaScript, and Python. Travis CI makes it easy to test and deploy code changes automatically, and can be integrated with popular code repositories like GitHub. After that, I introduced him to Circle CI, another cloud-based platform that supports multiple programming languages and integrates with several tools and services. Circle CI can automate the testing and deployment process and can help teams collaborate more effectively. Then, I told him about GitLab CI/CD, an open-source platform that's built into the GitLab source code management tool. GitLab CI/CD can be used to automatically test and deploy code changes and can help teams collaborate more effectively. Finally, I introduced him to Bamboo and TeamCity, two popular tools used for continuous integration and deployment. Both tools support multiple programming languages and integrate with several tools and services, making them ideal choices for many development teams. Tom listened carefully to my explanations, and I could see that he was impressed by the variety of tools available for continuous integration in DevOps. It's important to choose the right tool for the job, and automating the build, testing, and deployment processes can help teams deliver high-quality software quickly and efficiently.
Describe how you might use Docker with Jenkins and what advantages you will gain.
Using Docker with Jenkins provides a powerful and flexible approach to building, testing, and deploying applications. By defining a Docker file in the code repository and using Jenkins to build, test, and deploy Docker images, you can ensure that the application and its dependencies are consistent and repeatable across different environments. Docker also provides benefits such as isolation, scalability, speed, portability, and security, which can improve the efficiency and reliability of the software delivery pipeline. Overall, using Docker with Jenkins enables you to manage dependencies, test environments, and deployment configurations in a consistent and repeatable way, automating the entire build and deployment process, from code commit to production deployment, to help improve the speed and quality of software delivery.
That's true, Daniel. With a Jenkins pipeline, you can easily automate your build and test process in a Docker container, ensuring that your tests are run consistently across environments and that your builds are reproducible. Please whiteboard some pseudocode for such a Jenkins pipeline, explaining how the code works.
In this pipeline code, we define 3 stages: build, test, and deploy. The pipeline is set to use a Docker agent, which means that all the commands in the pipeline will be run inside a Docker container. The Docker image used in the container is specified by the image parameter. In the build stage, we install the project's dependencies using the npm install command, as an example. In the test stage, we run the project's tests using the npm test command, as an example. In the deploy stage, we specify that this stage should only run on the master branch using the when directive. We then build a Docker image using the docker build command, push the image to a Docker registry using the docker push command, and deploy the application using Kubernetes using the kubectl apply command. Of course, this is just a high-level overview, and the exact pipeline code will depend on the specific needs of your project. However, this should give you a rough idea of what a Jenkins pipeline for running tests in a Docker container might look like.
In AWS, what technology might you use in place of Jenkins?
AWS Code Pipeline is a managed continuous integration and delivery service that can be used as a replacement for Jenkins. It automates the build, test, and deploy phases of the release process, based on the release model of your choice. Code Pipeline integrates with a variety of AWS and third-party services and provides features like pipeline visualization, manual approval steps, and support for multiple source code repositories. By using Code Pipeline, you can eliminate the need for maintaining and scaling your own Jenkins infrastructure and enjoy better security, reliability, and scalability. However, if you require more customization and control over your CI/CD process, Jenkins may still be a better option.
How might you use Jenkins to manage multi-branch projects?
Using a multi-branch approach in a Jenkins project is a common practice that helps keep the main branch stable and deployable while still allowing for development of new features and bug fixes in parallel. For instance, a typical setup may have a master branch, which represents the stable version of the application, and a develop branch, where you integrate changes from feature branches and prepare the application for release. You can also create feature branches for specific features or bug fixes, release branches for preparing for a release, and hotfix branches for critical bug fixes in production. This approach allows you to isolate changes to specific branches and perform separate build and test processes, which helps you catch errors and bugs early in the development process. By using a multi-branch approach, you can effectively manage the development and release of your project while ensuring that your main branch remains stable and deployable.
How do you configure Jenkins to trigger a build when code is pushed to a Git repository?
To configure Jenkins to trigger a build when code is pushed to a Git repository, you can install the Git plugin in Jenkins, create a new Jenkins job, select Git as the source code management system, enter the repository URL and the branch to monitor, and configure the build steps for the job. Under Build Triggers, you can select Poll SCM to have Jenkins periodically check for changes, or select Build when a change is pushed to GitLab, or GitHub Hook Trigger for Git SIM polling, to have Jenkins automatically trigger a build when a change is pushed to the repository using webhooks. This helps you speed up your development cycle and catch errors and bugs early in the development process.
What is Jenkins X, and how is it different from traditional Jenkins?
Jenkins X is a cloud-native, open-source platform for continuous delivery built on top of Kubernetes. It provides an integrated and automated pipeline for building, testing, and deploying applications, and supports best practices such as GitOps and ChatOps. Jenkins X is designed specifically for cloud-native development and deployment, with features such as preview environments and pull request feedback that improve the developer experience. It also supports multiple cloud providers such as Google Cloud, AWS, and Azure, making it easier to deploy applications across different environments and clouds. Overall, Jenkins X offers a modern cloud-native approach to continuous delivery that emphasizes automation, best practices, and developer experience, making it a powerful tool for building and deploying cloud-native applications.
Name some popular Jenkins plugins, and briefly describe what they do.
Jenkins plugins extend its functionality and integrate it with other tools and services, including popular plugins like Pipeline, providing DSL for defining Jenkins pipelines, Git, providing integration with Git SCM tools, Docker, providing build and run Docker containers, JUnit, providing publish JUnit test results, Maven, providing integration with Maven build tool, Ansible, providing automation of infrastructure and application configuration and deployment, Slack, providing send notifications to Slack channels, and SonarQube, providing continuous code quality management.
Describe an incident where your DevOps build automation and testing strategy saved the day.
It was a typical Monday morning at the headquarters of a large e-commerce company. The development team had been working on a major update to their website for weeks, and the release was scheduled for that afternoon. Everyone was nervous but excited to see their hard work come to fruition. However, things took a turn for the worse when one of the developers discovered a critical bug in the code. The bug was causing the website to crash intermittently, and the team had no idea how to fix it. With the clock ticking down to the release, the project manager called an emergency meeting with my DevOps team. My team quickly got to work, analyzing the code and trying to isolate the source of the problem. Using our extensive knowledge of automation and testing strategies, my team was able to quickly identify the root cause of the issue. We implemented a fix, and then ran a series of automated tests to ensure that the bug had been completely resolved. Thanks to the fast action of my team, the bug was fixed in record time. The updated website was released on schedule, and our customers were thrilled with the new features and improvements. The incident had been a stressful one, but it was also a valuable learning experience for my team. We realized the importance of having a strong DevOps strategy in place, and went to work integrating automated testing into the full development process.
As a software development team, we have always struggled with maintaining code quality and ensuring adequate code coverage. We are constantly grappling with bugs and errors that keep creeping up even after several rounds of testing. As our lead DevOps engineer, how would you help us catch bugs and errors early in the development process, reduce our overall cost and time required for testing?
Begin by implementing code quality metrics such as code complexity, maintainability, and readability using tools such as SonarQube and Code Climate. These metrics will help identify areas of your codebase that need improvement and allow you to address them proactively. Next, focus on code coverage metrics using tools such as Jacoco and Cobertura. By setting coverage targets for each feature and enforcing them using a continuous integration, continuous deployment pipeline, you will be able to ensure that your code has been adequately tested before release. Next, implement automated testing using tools such as JUnit and Selenium. This will help catch bugs and errors early in the development process, reducing the overall cost and time required for testing. Finally, integrate all these metrics and tools into your CI/CD pipeline using DevOps practices. This will help achieve a high level of automation and ensure that your code quality and coverage metrics are consistently monitored and reported. Using this approach, your software development process will become more efficient and reliable, enabling you to deliver high-quality software quickly and with greater confidence.
This sounds like a promising approach. Can you provide an outline of the best practices for continuous integration that we could implement in our program?
Here are some best practices for continuous integration. 1. The build process should be automated, triggered by code changes in a version control system, and should run the necessary tests and checks before the build is considered successful. 2. Use a version control system to manage code changes, and configure the CI server to trigger builds when changes are pushed to the repository. 3. Build in a clean environment to ensure that builds are reproducible and that dependencies are correctly managed. 4. Tests should be automated and run as part of the build process, with test results being reported back to developers. 5. Keep build times as short as possible to reduce feedback times and ensure that developers are not blocked while waiting for builds to complete. 6. Use feedback loops to provide developers with rapid feedback on the status of builds and tests, enabling them to identify and fix issues quickly. 7. Continuously integrate changes into the main branch to reduce the risk of integration issues and conflicts. 8. Monitor build and test results to identify trends and issues, and use this information to continuously improve the CI process. By following these best practices, teams can ensure that their CI process is reliable, efficient, and provides valuable feedback to developers throughout the development process.
You've mentioned Git previously in our interview. Please outline a Git training course that you might teach to our development team.
I would cover the following topics in my Git training course. 1. Understanding version control and Git. 2. Learning how to install Git on your machine. 3. Creating a new Git repository. 4. Adding and committing changes to a repository. 5. Understanding branching and merging. 6. Collaborating with others using Git. 7. Working with remote repositories. 8. Using Git to manage projects efficiently. Additionally, this course would include hands-on exercises, quizzes, and projects to ensure that learners can apply Git in real-world scenarios.
Of the topics you've listed, which one do you find most challenging for developers?
I find branching and merging the most difficult for developers to master. Branching and merging in Git require a good understanding of the underlying data model and how Git tracks changes across multiple branches. Moreover, resolving conflicts that may arise during merging can be challenging, especially when working with multiple developers or when managing changes across multiple environments.
Thanks, Daniel. That makes sense. Along the same lines, can you provide information on what AWS uses for its Git control?
AWS offers AWS Code Commit, a fully managed Git service that is highly scalable and secure. It enables developers to store and manage their code securely in the cloud and integrates with other AWS services such as AWS Code Pipeline, AWS Code Build, and AWS Code Deploy, providing the capability to create fully automated continuous integration and deployment pipelines. Code Commit provides developers with the ability to host private Git repositories, collaborate with others using Git, and use Git workflows for their projects. Additionally, Code Commit includes features such as access control, branch-level permissions, encryption, and automatic backups to ensure the security and reliability of the code repositories.
As opposed to the developer, what is the most difficult Git task for the DevOps engineer?
In my opinion, the most difficult Git task for the DevOps engineer is using Git with infrastructure as code. Infrastructure as code, or IAC, is an approach to infrastructure automation that uses declarative code to provision and manage IT resources. IAC tools such as Terraform, Ansible, or CloudFormation enable DevOps teams to manage infrastructure as if it were software code, allowing them to version, test, and deploy changes in a repeatable and predictable manner. However, integrating Git with IAC can be challenging, especially when managing multiple environments and dependencies. For instance, Changes to infrastructure code in one environment may impact other environments, requiring careful coordination and testing. Moreover, infrastructure changes may have security and compliance implications that need to be addressed in the DevOps workflow. So Sanjay, has your organization used the git blame command?
No, we haven't. What does it do?
Git blame is a git command that shows the author and last modification time of each line of a file. It can be used to find out who made a change to a particular line of code and when that change was made. To use git blame, open a terminal window, navigate to the directory that contains the Git repository you want to work with, and type in git blame, file name. Along those same lines, have you used git tags?
No, we haven't. What are those?
In Git, a tag is a named pointer to a specific commit in a repository's history. Tags are used to mark specific points in history, such as release points or major milestones. They are often used as a way to organize and reference commits that are important to the development and release of a software project. Sanjay, you may also find Git workflow useful in your DevOps program. A Git workflow is a process or set of guidelines that teams use to manage their code changes and collaborate on a project using Git version control. The right workflow for a team depends on the development process and project needs, and there are many different workflows to choose from, including the centralized workflow, feature branch workflow, Git flow workflow, forking workflow, and release workflow. The key to successful Git workflow is to choose a workflow that fits the team's needs, communicate and enforce the guidelines consistently throughout the team.
Thanks, Daniel. We will take a look at that. Moving on with the questioning. Please explain the difference between Git and GitHub.
Managing a software development project with a team of developers can be challenging, especially when you have multiple developers working on different features and changes. In this scenario, Git can be a useful tool as a distributed version control system that allows each developer to work on their changes separately and merge them together later. Git makes it easy to track changes, revert to previous versions, and collaborate with other developers. However, Git alone may not be sufficient for managing the entire development process. This is where GitHub comes in. GitHub is a web-based hosting service for Git repositories that provides additional collaboration and project management features. With GitHub, you can host your Git repository in a centralized location, manage your code changes, create and manage issues, pull requests and code reviews, and collaborate with your team in real time. You can also integrate continuous integration and deployment tools to automate your development process and ensure code quality. By using Git and GitHub together, you can manage your software development project with ease, collaborate effectively, and stay on top of your development process.
Daniel, what is the main difference between continuous delivery and continuous deployment?
Continuous deployment goes one step further than continuous delivery by automating the deployment process, so code changes are not only built, tested, and prepared for release, but they are also automatically deployed to production environments as soon as they are ready, without requiring any human intervention. In other words, continuous delivery prepares the code changes for deployment, while continuous deployment automatically deploys the changes to production.
Thanks, Daniel. You've progressed to the next stage of our interview process. Let's go meet Samantha, our lead DevOps engineer. She will be assisting in the next phase of your interview.
Hi, Daniel. Nice to meet you. I've heard great things about you.
I'm happy to meet you as well, Samantha. I look forward to our interview.
Daniel, let's use our imagination and explore a continual deployment Starship. Can you describe how Docker, Kubernetes, Helm, Ansible, and Terraform would fit into the various systems and functionalities of the vessel?
Okay, that's a good one. Here's a memory palace for a continual deployment Starship. As I strolled through the Starship, I couldn't help but marvel at the intricate systems that powered the vessel. Docker, the storage system, was like a library of modules and containers, each containing a unique set of functionalities, awaiting the crew's command. As I turned the corner, I stumbled upon the control center, Kubernetes, the conductor of the ship's symphony of systems, orchestrating the deployment and scaling of the ship's various functionalities. My attention then shifted to the navigation system, Helm, which acted like a compass, guiding the crew to the ship's different systems and functionalities. I then stumbled upon the automation system, Ansible, like a magician's wand, empowering the crew to perform tasks and functions without manual intervention. Finally, I arrived at the infrastructure system, Terraform, which managed the ship's resources, like a captain managing his ship's vital resources, ensuring the vessel ran smoothly. It was awe-inspiring to see how each component worked together in perfect harmony, like a well-oiled machine, to power the Starship.
Turning our attention to Docker, how would you manage your secrets in Docker?
Managing secrets in Docker involves ensuring that sensitive information is stored and transmitted securely. This can be done using Docker secrets, passing secrets as environment variables, or using external secret managers such as HashiCorp Vault or AWS Secrets Manager. Regardless of the method used, it's important to ensure that secrets are stored securely and are only accessible by the containers that require them. Secrets should be rotated periodically, and access to secrets should be audited and monitored to detect any potential security breaches.
What are some of your favorite Docker log commands? Please give an example of one.
Docker log commands are used to view and manage the logs generated by Docker containers. Here are the log commands I use the most. The Docker logs command allows you to view the logs for a specific container, while the F option allows you to stream the logs in real time. The tail option allows you to view a specific number of lines from the logs, and the since option allows you to view logs since a specific time. The timestamps option allows you to view the logs with timestamps. These commands are useful for monitoring and troubleshooting Docker containers, identifying errors, and diagnosing issues. For example, if you want to view only the last 20 lines of logs, you can use the following command: Docker logs, tail 20, file name.
Can you explain the difference between CMD and Entrypoint in a Docker file?
CMD and Entrypoint are both instructions used in a Docker file to specify the command that will be executed when a container is started. The main difference between them is that CMD provides a default command that can be overridden at runtime, while Entrypoint specifies a fixed command that cannot be overridden at runtime. When used together, Entrypoint sets the primary command to run when the container starts, and CMD provides a default argument for that command that can be overridden at runtime.
Please give an example of some common challenges you've faced when working with Docker, and how you overcame them.
Oh boy, that's a lot. Where do I start? I started my DevOps career working with a team of developers who wanted to adopt Docker for our application deployment. We heard about the benefits of containerization, such as improved scalability and portability, and decided to give it a try. At first, we encountered networking issues when trying to get our containers to communicate with each other and with the host machine. We realized that we needed to properly configure our Docker network settings to allow for proper communication. After some research, we created a custom network and were able to resolve our networking issues. We then faced storage issues as our containers generated large amounts of data that needed to be stored persistently. To overcome this, we started using Docker volumes and bind mounts to store data outside of the container. We also became increasingly concerned about security issues and implemented best security practices to ensure that our containers were secure. As our application grew, we found it challenging to manage multiple containers. We started using Docker Compose to define and orchestrate multiple containers and services. This allowed us to manage container lifecycles, scaling, and load balancing more effectively. We also integrated our Docker containers with other tools and technologies, such as databases, APIs, and message queues, using Consul and Zookeeper for service discovery and configuration management. Finally, we realized the importance of version control when working with Docker, and started using a version control system like Git to manage our Docker files and track changes to our images over time. Through hard work, we were able to successfully deploy our application using Docker and saw the benefits of containerization in action. Did I answer your question?
Just another question along these lines. How do you secure Docker containers?
Best practices for securing Docker containers include using secure base images, keeping images and containers up to date, using strong authentication, limiting container privileges, using secrets management, enabling container isolation, and implementing network security. Container orchestration platforms like Kubernetes also provide built-in security features to help secure Docker containers. A well-planned and executed security strategy can help minimize the risk of security breaches and ensure the safe and secure functioning of Docker containers.
Daniel, presently our group uses Docker Swarm, but we have been discussing moving to Kubernetes. Can you explain the difference between Docker Swarm and Kubernetes and why you might choose Kubernetes over Docker Swarm?
Docker Swarm is a simpler and more lightweight option for smaller applications or organizations that are just starting with containerization. It provides basic orchestration features such as service discovery, load balancing, and auto-scaling. Docker Swarm is tightly integrated with Docker, which can make it a simpler and more familiar choice for developers who are already familiar with Docker. On the other hand, Kubernetes provides a comprehensive set of features for managing and deploying containerized applications at scale, such as automated rollouts, declarative configuration, and advanced networking. Kubernetes also has a large and active community of developers contributing to its development, which means that it has a wider range of tools, plugins, and add-ons available. Additionally, Kubernetes has strong support from major cloud providers such as Google Cloud, Amazon Web Services, and Microsoft Azure, making it a widely adopted and supported platform for container orchestration. Ultimately, Kubernetes is a better choice for larger, more complex applications with advanced container orchestration needs that require a more powerful and flexible platform with a wider range of tools and resources.
Daniel, we appreciate all your great answers. We would like to shift gears and test your competence on the keyboard.
Sure, sounds like a good time.